Today we will be working on a problem from Exam 1, Part 3, Question 5. So the first step we can take is by reading the problem. And this problem is asking us to find the amount of force from Q1 on Q0 with the following information. Which brings us to step 2, which is identifying the what. So what do we know? We know that Q of 0 is equal to negative 1.1 times 10 to the negative 4 coulombs. And we know that the charge of Q of 1 is equal to positive 5.7 times 10 to the negative 4 coulombs. We also know that the K constant is equal to 8.99 times 10 to the 9 SI units. And because this is a question from the exam, you can refer to question 1A for a visual. We know that the distance between Q0 and Q1 is 1 meter. So now we can move on to step 3, which is to identify the correct equation to use. For this problem, we can use Coulomb's law, which gives us an equation that F of C is equal to the K constant times the absolute value of Q1 times the absolute value of Q2 over R squared. But since we are trying to find the force between Q0 and Q1, we will use F of C is equal to the K constant times the absolute value of Q0 times the absolute value of Q1 over R squared. We can then plug in the values from the what do we know section into this equation. After plugging these numbers into my calculator, I am left with an answer of 563.67. However, I want to clean this up a little bit into scientific notation. So we are left with F of C is equal to 5.6367 times 10 squared newtons per coulomb. And that, my friends, is the final answer.